Okay, hello and thank you for joining us for this, Autodesk's latest webinar with car design news. My name is Uwe Rossbacher. I'm the editor of Interior Motives magazine. As you know, this webinar will focus on virtual design workflow in the automotive arena. Over the next half hour or so, we'll be joined by Autodesk's Uwe Rossbacher as he showcases the latest virtual techniques with physical 3D models. Uwe brings 16 years of automotive surface modeling experience to his role as industrial specialist for technical surfacing and styling at Autodesk. His job involves communicating with designers worldwide to enable their development teams to come up with cutting-edge technology solutions. Prior to joining Autodesk, Uwe held technical positions at ISEM and Alias, and most recently worked at a Volkswagen concept studio in Germany. Before we start, I'd like to invite all of you attending this webinar to draw up some questions as you listen to this fascinating topic, which Uwe will then be pleased to answer in the question and answer session that will follow immediately after his presentation. You can ask these questions by typing them into the box at the bottom right-hand side of your screen. If you experience any technical issues during the session, please type a message detailing the problem into the same box at the bottom of the screen, and our team will do their very best to resolve them. We hope you'll find this webinar stimulating and informative. It's now time to hand you over to Uwe so that he can begin his presentation. Over to you, Uwe.
Welcome, everybody. I hope everybody can hear me. It's a bit awkward to sit just in an office somewhere in the world and hoping that everybody understands me. I guess it will be like that. So this webinar will be about virtual techniques in the design process. We see virtual techniques, we see physical 3D models, and how do we live with both will be a topic here. Another topic is about virtual techniques that we can see here. There's freeform modeling in concept, there's Class A modeling, there's virtual clay, and so on. And this webinar will introduce some of these techniques in order to give you a better understanding about this wide field of possibilities. In today's automotive business, there are a lot of things going on, and especially the appearance and the dealing with virtual techniques with software gives us two questions that I hear very often. What software I should learn, and what software should I purchase or give to my designers? And I would like to answer both questions, or I would like to give an idea about the answer of both questions. In order to do that, I think it's okay, it's good to see to clear the field that we are in, to clear the field of the design process. Usually it starts with sketching, or usually it starts with an idea actually. And I think the best possibility to capture an idea is sketching. There's traditional sketching with pencil and paper. And there are digital techniques. These digital techniques are helping us to bring out or to develop new styles and supporting us to save some time. But I believe that even here we can see that there's nothing that replaces talent and skills. And I think this is the base for handling digital tools. We can see it already in sketching. Autodesk offers here Sketchbook Designer as a digital sketching tools that we can work with. The next thing could be a phase called fast concept modeling, right? Here it is about developing the initial idea a little bit further. Often it doesn't matter if the form then will be a shape that has nothing to do with a car, where there are no wheels or maybe no windshield wipers or no rear mirrors, nothing. There are entire teams at automotive OEMs doing nothing else but just forms that are no cars. And this stage is for developing the initial idea a little bit further. The next thing could be a design surfacing. Here in design surfacing we see a model that has already all the attributes defining a car. We know there are lights, there are wheels and all that stuff, and the model looks very much like a car. Since we use virtual techniques in here, and it's a good idea that we do that because we have global sites and they all produce nice designs, and these designs should be communicated all over the world, and the virtual techniques allow that pretty well. The other thing is that we have simulation, something like that as well, influencing the design process, and they all require digital models. But when we have a digital model, when we have virtual techniques, then we have the ability using visualization technologies. And these visualization technologies allows us to make a design kind of photorealistic. And I see here a danger, because a design model that is probably not ready yet can create, when it's virtual, can create the desire to be photorealistic, to make it or to show an illusion of what could be. A designer very easy can say, hey, I would love to see real metal, real glass. I want to see all these tricks to make my idea become true, become a perfect illusion. And often I see here in this stage that we have to pay a price. The price that is with less attention on a structural focus, on the page layout of these kind of things. And that, I think, is it's a big risk here. The next part in the process is it's not a process from a book or whatever, but let's call it Class A surfacing. And in the Class A surfacing area, there's a lot of mysticism and a lot of questions about that. The basic issue is Class A surfacing has higher approaches on some things. For instance, on highlights. The model that we can see here is a Class A model. Well, it looks like the design model. I put in the design model as well, and there are just slight differences. I show here right now some red arrows, and these red arrows specify regions that are slightly different. We can see here the blue shading on the wheel lip, on the wheel opening, and we can see the red or the orange and green shading on the C-pillar diving into the rear of the car. And you can see here there are slight differences. And the Class A teams, they are doing those slight differences. And this is not not an easy task, because it requires a complete patch structure, a structural approach enabling those things. They are not coming for free, and they are not coming with an easy thing. Very often an entire model has to be completely redone or remodeled. The other thing with Class A is that these Class A teams, those Class A teams are incorporating engineering approaches and approaches from the law. Certain restrictions about minimum heights, about minimum radii, and so on has to be incorporated in order to speak about Class A. This outlines a process from the initial idea documented with sketching, doodling, with easy things, until Class A surfacing. And we can cover this process with software. Sketchbook Designer could be from the Autodesk perspective from the beginning. We can do some concept modeling with Maya, for instance, and then Alias as a NURBS modeling software could cover the rest. But this virtual coverage of this process is not everything. Along this process, we have a lot of interaction with the 3D, with the physical world. it can be sketching with a pencil, it can be working with clay in different scales, quarter scales, full scales, and so on. And it's not just like this. We have here as well an interaction with, let's say, marketing departments requiring images. Images, for instance, like the image of the interior that we see here, that is not possible to do it on a real car. I mean, this is a thing definitely from a virtual shot. Or the opportunities that we have with simulation to act with simulation very early in the design process. All this requires interaction between the virtual world and the physical world. We need both. We need the virtual world to make it efficient, to make the process efficient, and to react on all these economy reasons that we are facing. And we need the traditional, the real, the physical world in order to use our senses of smell, of touch, and to make then design human and to make design real. So we need both worlds. In order to jump between these two worlds, we are using clay mill, or we are using milling, and we are scanning the milled objects to capture the shapes. But unfortunately, we are losing things like object structure, like colors, like patch layout, all these assets or elements that are possible as well in the virtual world and that are playing there a big role. And because of this loss, I'm thinking that jumping out of the digital world into the clay world could be, and I say here really could be, a one-way street. I understand that we have to have the ability to touch clay and to see the model in reality. But I do think that the loss of information when we want to come back into the digital world is too high. And I see here a possibility that the digital sculpture is always together with the designer to discuss changes on the model, that the sculptor is not getting a scan or something like that and is doing a reverse engineering kind of work, that the digital sculptor is there to tell the designer the impact on his new ideas, because the digital sculptor knows the structural underlying of the model, and the designer is there as well to make the digital sculptor understand how, on which way his modification was intended. And so we can make sure that the digital model can be the master model. And reverse engineering parts in this stage, I think this is connected with a lot of loss of information. And I don't know if this is approachable or if this is okay, if somebody can afford that. And that's why I would say this should be a one-way street. So coming here or watching the entire process from sketch to Class A surfaces that can go into tooling or into downstream CAD, I can see or I can specify here two major things. We have a creative focus until we shape an idea, until we shape lots of ideas, select an idea, and then with a structural focus try to fine-tune and to finalize and to select, of course, one of those ideas. And here I want to go a little bit more into detail, and I'm starting with the creative focus. That creative focus usually starts with a 2D idea. So the designer usually would do some scribbling, do some doodling to capture an idea. I remember in one studio I once worked, somebody said, "Oh, big wheels are always looking good," because he made sketches that would never work and the wheels were always too big. But here it's about just a kind of an outsourcing of an idea. You can do that with software as well, with virtual techniques, and you will work here very often with brush-based, pixel-based techniques that are simulating just a pen and simulating paper, and then start with that. Autodesk offers here Sketchbook Designer to do this kind of work. Brush techniques and pixel-based. Another step could be when you then try to eliminate the variation of different views. The designer here chooses the side view because it's reproducible, and here he tries right now to bring more details into his idea. And there, again, when we use virtual techniques, vector-based techniques are in the foreground. The big thing here is to detail the idea a little bit more in order to come up with something we can use in the next step. Here we can see I don't like it so often, and I don't do it very often, I don't like it so much, and I don't do it very often to show UIs. What I do here. The UI is a UI from Maya. We imported here into Maya the sketch, and we imported a 3D model of a package and some wheels in order to give the design idea a better determination. And why Maya? Maya is a technology that is purchasable right now. I mean, you can go right now and order this. It works. Companies are already working with that. It's a known thing. It's a tested thing. And it is a software that offers, even when it offers a lot of functionality, it allows me to focus just on one part, on the modeling part. I want to model here, I want to determine my design idea with a little bit of the 3D world. And that's why I'm doing it here in Maya. Again, I could use software packages that are around. I did that here with Maya because I need to be able to see the sketch and the 3D curve. On a side note, it is interesting to know that these 3D packages are usually coming from CAD files. Let's say it's an NX file or it's a V5 file. And it's very helpful to open these huge files in the software that you are using in order to sort out the file and in order to turn on and off layers and stuff like that to see just what you need. And this is another reason why I choose here Maya. Finally, Maya is an Autodesk software. You shouldn't forget that. The whole thing is about creating fastly volumes. The wheels are carryover parts. It is about the volume thing. The good thing here is that this model is always closed. So as soon as I decide to mill it out for some checking issues or whatever, I can do it right away because it's always closed. Another thing what I really find impressive, and I find it impressive because I consider myself as a NURBS modeler, you can model here, you can model, let's say, freely. That means you can model whatever you think about. When you are modeling NURBS, you know, oh man, there are restrictions and there are lots of hassle that you don't have to deal with when you use virtual clay, when you use a polygon model. This model then easily can be used for changes. For instance, with the red arrow here we can see there's a change in the center line, which is a dramatic change. It can be easily done in a polygon model. When I have to do this change in a NURBS model, oh my god, it would require a reasonable amount of time, really much. I really would like to point your interest here on these possibilities to use deformer in Maya. And at this time, I would like to mention that the next webinar with cardesignnews.com will be about using those techniques more in detail than I can do it. I cannot, well, we are not showing today what we can do here with this technology, but it will be the next webinar. Big changes, changes of proportions and something like that can easily be done using virtual clay. Whatever you find, whatever software you find can dealing virtual clay, it's good enough for this stage. The next thing is I would load this simple model into Showcase Pro. Why I do that? I like to do that because in this software I can render out the environment and the code, the metal, the glass, and all that stuff in a repeatable way. So I get a stage for all my designs, and the stage will always look the same. And then I can load this rendered model back into a 2D sketching program. In this case, I did it in Sketchbook Designer to do a 2D refinement, following the idea, sketch what is too complicated to model. For instance, lights, mirrors, grills, and stuff like that. And with this, I have the ability to get designs that are comparable, right? There is no design that sticks out because it has a very cool rendering techniques or some light effects or whatever. That's not there. Everything is the same, and so design becomes comparable. Could be very interesting for people amongst you who are responsible for a studio or responsible for doing those kinds of things. And the other approach is, well, this 2D sketch at the end of this game that I just sketched out has a 3D determination. So that means the design has the right measurements already, and we can be sure, well, it will fit into an appropriate cage that later on we will have. And yes, maybe the adjustment with engineering is already there, which is a good thing for the designer. For the guys amongst you who are designer, they profit from that as well. What's left? The ability of polygons in that process have a border. Have a border to do something in a reasonable time frame and with a reasonable effort. Of course, I don't want to say they cannot do certain things, but there's a border within a certain time, within a reasonable time, and that border is with details. Virtual clay or polygons, they have a problem because the stuff that I know from the NURBS work, trimming, is not possible there. So that means when I'm used to NURBS, and when I want to add a detail, I can just trim the surface, and the highlight picture and the structure of my underlying surface stays the same. But in Polygon modeling, when the user wants to add a detail, he destroys the underlying surface and makes it smaller, it changes it a little bit, and so it's harder to do details, and it's harder to reach a certain level of details, you know, to show for the lights or even other things. And there is no discussion that probably some Polygon models are good light models, and that's all okay, and I will never deny that. And in general, I think I'm okay with this. The other reason for saying there is something left is the controllability of highlights. For a board presentation, when you show a car or an interior in full size on a power wall, you better make sure that the big bosses look crisp highlights, or that they see very good highlights. And here I see a problem I guess problem is not the right word, but I use it anyway. It's not an English class here. This polygons cannot do it that good. So I can see that there is a need for doing something else. NURBS surfaces actually could do that. With NURBS surfaces, I can model details and I can control highlights in an appropriate way. This is an advantage, yeah, but it has a big disadvantage as well. NURBS surfaces are not like digital clay. Everybody knows that who tries to change or to apply big changes on a NURBS model, almost impossible because it takes too much time. And now the question is then, when do we start with that NURBS modeling? And then another question that I didn't write here is, and with what NURBS modeling do we start? We see here the big picture, which is a little bit with bluish wireframe, shows a hood that is modeled with a kind of a structural focus. You can see a main surface and you can see big blends, a small fillet, another main surface, another little fillet. And the surface above in that little picture that is framed in black, you can see it's a NURBS model as well, but it doesn't. It is a model without much structural focus and just capturing the design idea. The question here is really with what we should start and when should we start. But before I answer that, I will put myself in the corner and say you should start with a structural focus on it, and I will sketch out how to do that, because I believe there's a lot of questions around how to do that. So let's see what I have. Let's see what I have in the area of a structural focus. I would recommend, oh, by the way, before I say more, I want to say that in no way I claim the wisdom to know everything about this. I know there are lots of ways to accomplish a goal. At the end, it's just the need of a nice car, of a nice surface model. But there are lots of ways to go there. I know and I've seen one way, but in no way I would say it's the only way. Okay, coming back to surfacing and to build surfaces with the structural focus. The first what I would recommend is, as a kind of a lesson, try to capture this design idea with volume pixels, like Lego. Try to build it with Lego in order to understand what the design is. I think it's just a mental lesson. Don't do it with software or whatever. Just try to build it, and just when you are at the beginner level. Here it becomes interesting. I would suggest it's the second step, do basic volumes, no surfaces. So the cubes right now are bigger. There are no cubes anymore because the outside surfaces can be a bit bulged. And I would recommend to try here to capture the intended idea. So you can really try to match the look of this basic volumes through the car that you want to model to the design idea that you have in mind. These are two preparation steps to do finally the surfaces. And I think that they are necessary in order to make it right. I would like to summarize that. I start with understanding the sculpture, doing some Lego with these volume pixels or with little cubes. The next thing is understand the basic volumes. I did that here as an example for a hood of a little mini, and then just then you do the surfacing. You do the surfacing like you would coat, like you would cover the volumes that you did before. So the goal is a surface model, but you are starting with trying to understand the basic volumes that are included to that. Of course, you don't have to do it like this, but I want to show you a risk. I have here a result of somebody who started too early with NURBS. In his mind, he put the basic volumes into place, and then he immediately, without having the volumes and seeing the volumes, he started to surface them. And he did a hood that I show here with the control point pictures in a way that is not appropriate. I show you right now how the surface model should look like. You see that the hood in the surface model, in the final surface model, is way smaller. And this is a major problem that can occur when we are not taking care that we cover the basic volumes with surfaces. Surfaces are like a curtain or something like that. We just cover them. And with this methodology, I would say I think it's possible to do light surfaces. I really try to figure out what is the secret of these cracks doing cool surfaces, and I think that could be a good possibility to start with. At the end of this game, you get a model. This model here is not a Class A model because all the fillets and the engineering approach work and so on is missing. But this model is a model with a structural focus that can be given to somebody else and he can read it. And he can read it because he can see fillets, main surface, secondary surfaces, and so on. And that model can be given then to somebody else, doing more time investment to reach Class A status when it's appropriate. So right now I would like to come back on the process again. So we accept that there's a creative focus and there's a structural focus. And given the stuff that I just said, I think that in the creative focus there could be a use of polygon modeling, and I don't deny here things like subdivision surface modeling or T-spline modeling as well, but I want to see that first. Why do I have here now polygon modeling? It's because I can see it. Because I can purchase Maya right now, I can ask my friend to model because I am not very good in Maya. I can ask him right now to do that, and that's an essential part for me, that I really, really trust things I can touch and that I can see now. And for the structural focus, I see NURBS modeling. NURBS modeling for CAD. And that means NURBS modeling that is with light surfaces, with theorem modeling, and with a reasonable and good patch structure. On this point, I would like to focus, emphasize on Mr. Jacob von Schirmeister. He works in Germany, he's German, and in 2008 he had a speech at the Autodesk University in Las Vegas about theoretical modeling. I mentioned that as a kind of requirement for light surface, for NURBS modeling, let's say, and the details you can find, if you are interested in that, you can find in his speech. You can look them up in the Autodesk University 2008 internet stage. I don't know but I know that you can find it there. If not, then I can guide you as well. The big thing with theorem modeling is that it allows you in a very predictable way to deal with all kinds of blends of fillets and so on, and it gives you a repeatable and a readable model for the process. So if you're interested in that, Jacob von Schirmeister, he was a part of a group of many modelers working in Germany for a company called Smart, and they came up with this idea and they developed it much further. I'm pretty sure this idea probably appeared somewhere else too, but I just know it from them. So it's not my stuff, it's their stuff. And for time issues, I'm not able right now to mention everybody. Just this gentleman should stand as an example. And at the end, we have this Class A model. And with this Class A model, it is really important to talk about the highlights. Not just the highlights on the continuity, because a NURBS model is a patchwork. And it's not about the continuity it's not about only the continuity between the borders. It's about that the highlights, the inner highlights of a patch fits to the inner highlights of another patch, of the neighbor patch, so that everything fits together, so that you can turn off the wireframe and you see an entire sculpture, and you cannot see with the highlights where was a patch border and where not. And it has to fit engineering criteria. And just then we talk about the Class A surface. I think it was last year or 2 years ago on cardinalDesignNews.com, you can find the recordings of a webinar I did about Class A surfacing. There was a little bit more details about, or not a little bit, there was much more details about this, and it shouldn't be a topic in this webinar. I would like to summarize what I said over the last 30 minutes. I think milling could be a good possibility for an output only. It's a one-way street. I said design just as precisely as needed. The next thing is when polygons come very close to be virtual clay, because they allow freedom of modeling. You can model whatever you have in mind, and because of the speed that they guarantee. And the last thing that I'm really convinced about is that if you model with NURBS, then do it with a structural focus, because this is the strength of NURBS. When you do it with a structural focus, then you really drive the NURBS car the right way. And the big question that comes at the end is, when should we start this NURBS surfacing? When? Is it closer to the creative focus? Is it closer to the other end where the structural focus is? I don't know. Every OEM, every car company is doing it differently. And every designer has to find out this view, or has to find out his personal view on this. I started with two questions. What software should I learn? What software should I purchase? And of course I would like to give two answers on that. The first answer is that, as I highlighted, this process is with many stages. And I'm not aware about one software that can do all of these stages. So I recommend to decide and to be aware, but at the end to decide for a particular stage and master this one. That would be my recommendation. And following the recommendation, you would have an answer about what software you should learn. The other thing is, I believe in mastering hand craftsmanship first, and use digital tools or techniques just for supporting the craftsmanship, and to use more styles or invent more styles, and finally to save time. I think that software is a tool, and you have to have the hand craftsman skills to apply those tools to your design intent. That is I think that is the big outcome of my work in several design studios around the world and the work for Autodesk. Autodesk here delivers many software, and I showed you all the software to be present in this process. But in order to master it, I think you must make a decision for where you are in that process and where you want to be in that process and where you want to earn money in that process. And with this, I'm at the end of this webinar, and I would like to give back now for the Q&A session.
Thank you, Uwe. Yeah, that was fascinating insight really into not only obviously some of the software and techniques, but also, I suppose, the kind of process and where it fits into the life of a designer. We've got a few questions for you that have come through from the audience here. One is, there's a couple of questions which really ask similar things, which is why is Maya better choice in the automotive creative process than 3ds Max?
Good. I understand that this reasonable question could come up, especially here in this webinar. The answer on that is I cannot give an answer. What I need is a software that is available today, that I can purchase today, and I need a software that allows me to work with digital clay. If 3D Studio Max is able to handle polygons in that way, that freely, and with that speed, it's all okay. If 3D Studio Max is purchasable, everything is okay. And so I cannot say Maya, yes, 3D Studio Max, no. I just choose Maya because I have to choose one. It's the same discussion, why BMW and not Mercedes?
Thanks, Uwe. Another one here from another listener is, which is the best strategy for a patch layout coming from Polygon data? Is there a best strategy?
Well, I'm not a general doing strategies. From my point of view, it's like this. When you come from polygons, I believe capture the shape, but throw everything away and try to understand with that method that I showed what kind of patches have to be in place. So the strategy is probably to figure out the biggest surface and to figure out what is the underlying surface that hold everything together. There are a couple of them, and try to develop a patch layout on this. But I don't want to look like an idiot here. That's why I'm saying the patch layout is a kind of a secret of this whole NURBS modeling thing, and it's not easily to be learned. And there's no way for me in a couple of seconds to answer these questions in order to satisfy you. The only thing I can say, everything that comes from Polygon modeling probably is not appropriate to serve as a patch structure in NURBS modeling.
Another one here. Do you think that this virtual clay will become a trend in the future? Are there any particular car brands using it in order to not lose the polygon structure and keep the design intent?
First, yes, I believe it will be a trend. A simple reason, so nobody, I'm not a god, and I don't know much, I don't know more about you actually, but I believe that with the global intention to save money and to bring out more design variations, there is no other way to gain speed and to gain more freedom, number one. And I think number two, many car companies, brands are using that already. There's a company with a big star. I think that they have no choice but using it. I think there's a company with two, a German company with two letters. They have no choice either to do that because they are to use it because that is a global brand, having cars in China, cars in South America, cars in Germany, in Europe and America, and they're only different variations, and every variation has a design, and that means speed, speed, speed.
Okay, another one here is, have you in your experience seen virtual tape drawings used at full scale, and can you describe any of its benefits?
The only virtual tapes that I have seen, and that doesn't mean that those things doesn't exist, it just means that I have a very limited experience as well, are tape drawings not in full scale. I worked once with a designer who gave a tape drawing in alias actually. He gave curves. And he put he gave these curves parameters about thickness and something like that, and so he had a shape. He gave it to me and say, "Can you deal with these curves?" And another designer even gave me 3D curves, but this was not one-to-one scale. And years ago, I have seen some kind of tape techniques by Bill Buxton. He is a scientist. He was working for Alias, now he works for Microsoft, I think, and he showed there something, but I haven't seen this in reality. Just on computer screens, this kind of drawings using curves and their thickness parameter.
The next question is back to Maya. It's from someone who's introducing Maya into their organization, and he asks, the designers are having a problem understanding it because they want to see and control lines like with NURBS models. Do you have any advice or experience with this matter?
First of all, I totally can understand this approach. I totally can understand that. The thing is that first of all, I would like to emphasize on the next webinar from Polygon Design News, because there we will have, by my colleague Martin Emilia, will have there more details and more insight of that. There are certain possibilities to work with lines, but I'm totally aware about the limitation of that. This process that we have right now is a process that we can purchase and we can do right now. We don't need to wait for any technology or anybody in the world. We can do it right now. Of course, it has a price. And I can see as well that there are limitations to deal with lines on a Maya model, because on a Maya model you start basically with a potato and you try to keep it as rough as possible, and then at the end you get details. While in NURBS you start with the details first, and so it's a whole different approach in Maya. And I would say, I would recommend the guy who asked the question, I would recommend to emphasize on the advantages of speed and of freedom that the designer would have. I know that there's a bevel technique is doing crazy beveling on the Maya model in order to do this kind of lines, and we all already got requests from companies doing that to put their more into Maya in order to develop functionality that are more reacting on curve input.
Here we have one more. Someone saying that sometimes we designers feel bad for not being Class A modelers. Do you think that Class A modeling is a must-have for industrial designers today?
No.
Okay, there's your answer. We've got, is there any way to model with polygons in Alias? I've been a NURB modeler for many years, says another.
No, there is no way. There's a way of handling polygons. In Alias they are called cloud. We call that, no, not cloud, I'm sorry. We call it scan, or no, another mistake. We call it mesh. We can handle meshes and do certain things with them, but we cannot model them. And so far, sirs, I have to say, so far I cannot see any attempt that we can model polygons in Alias yet. I believe, and I can see, no, nobody's interested in what I believe, but I can see a direction that Alias for many years already is going to be strong in NURBS modeling. But when it comes to polygon modeling, I cannot see there anything, and I cannot recommend it here at that stage for you, because it would be not very responsible for me. I can see at the moment that we can purchase products out there, and in Autodesk, in the Autodesk world, it would be a Maya product that would apply to that. But again, there are many other software products who can do the same thing. It is about virtual clay, it's about speed. And I cannot see that at the moment to be happening, or to have that inside of Alias. I'm sorry.
Thank you. One more here is, how does patch layout for Class A surfacing differ from quick conceptual surfacing in Alias?
when you do a quick conceptual surfacing, you have in your mind the idea, and you get even paid for that. Your design boss pays you for developing an idea. I think when you are a universal genius who is already capable to think about some engineering or law requirements, that's fine. But I think you should, as a concept modeler, you should concentrate on the concept, while a NURBS modeler who is in particular concentrated on a patch layout that fits engineering requirements, highlight quality, and all this kind of stuff will have a different one. The big differences are, when you remember, it's obvious that Class A patch layout is probably with lighter surfaces. It follows the theory modeling rules, and it has a patch layout that is reasonable, and which this is, I feel really bad, and I apologize to everybody that I cannot give a better thing. I feel horrible that I cannot give you a good definition for reasonable patch layout. That is, we need for that examples, and we need to show it, because I really would like to say it to everybody in the world, but I cannot. So theory modeling, light surfaces, and probably give a determination for every patch or for every segment that you put into your layout. I think that would be something I can say that makes a good patch layout for Class A surfaces.
Thanks again. We have another one here saying, there's a person saying that his clients demand those freeform surfaces, but they hear it's really hard to master this. What's your thoughts on that?
I want to be pragmatic here. I would suggest make a business decision. It's simple like that. Oh, it's simple like that. Make a business decision. If your clients are paying you enough in order for you to hire a professional guy who can do Class A surfaces, then do it. If they cannot pay enough money, and if this is not a real business case, then leave it. I have seen too much frustration and too much failings trying to force designers, concept modelers to do this kind of high-end engineering-like surfacing, and they didn't succeed. They didn't want it to succeed. They couldn't do it, and I wouldn't try that. So I would make a business case, because I believe for quality services, you need somebody who is doing it full-time and the whole day. That's the ugly truth of that. And that's why I think that Class A surfacing and industrial design has a kind of a different relation, because as long as industrial design can pay for it, fine. But in my experience, industrial design is easier with those kind of things, easier with payment as well, easier with the business case as well. And that's why I said no to Class A surfaces in industrial design, considering that design surfacing is already much more forward than years ago, and I think it should be enough for industrial design purposes.
Here's another question which is quite specific to Autodesk. Do you think that Tsplines, which I think is a company recently acquired by Autodesk, do you think that Tsplines is the lost link between a creative approach and NURBS modeling?
Yeah, again, I'm not God. When you ask me what I'm thinking, it could be. The thing what Tsplines theoretically could do is very promising, and in that manner it could be a link. But in order to protect my own credibility on that, I have to say I say something about it when I see it. And so far I have seen very cool attempts, very, very cool prototypes, and I know mathematically that this technology can be very promising, but I want to see software that I can purchase. please remember that thing what I said about Maya. I need to purchase it, I need to be able to purchase it, and I need to be able to try it out now. And I'm talking about now. And I want to be, because tomorrow later you go back to work and you have to work. And I would like to give you a kind of an advice an advice for that. Tsplines has a potential. Let's see what Autodesk is doing out of it.
One more here coming from our readers is how much of Class A CAS model data can be reused by engineers in CAD?
The thing with Class A is that the definition of Class A for every car company in the whole world is different. Tolerances are interpreted different. VW wants this, BMW doesn't like this, and everybody has something different. And so the whole thing with Class A surfaces is dependent on each client that we have. And so I think when the Class A model is with what I have some experience with Volkswagen, for instance. I worked there actually. And with Class A models over there, I experienced that they have an aspect of readability. They have to be readable by a lot of people. And when those surfaces are staying, then I think they are easily reusable. But when these surfaces are going over some IGES formattation or whatever, and opened in CATIA and then saved and blah blah blah, then it could be that a Class A model with a certain patch structure finally gets a patch structure that I cannot deal with anymore. And then I think this effect goes away. So everything what I was talking in the webinar was considering a company who is able to invest enough money into such a process, has departments that can do that kind of thing. It doesn't need to be just automotive company. A big company in San Francisco doing industrial design, they do it the same way. So to answer the question, it depends on where or what was happening with the Class A model, how much translations and so on, and how was the Class A process. I know it's bad. I know that you want to have answers on the point, but believe me, this is not easy to answer so easily.
Okay, we're just coming up on an hour now. So this is our final question from the audience, Uwe. Is probably something that kind of covers, I suppose, the whole topic, and its sort of fundamental question about modeling really and the role is. They ask, how much of a designer is a modeler? Is he or she just executing, or can they make real design decisions?
That's a good question. Actually, it's a very good question. I love it. From my point of view, there is in the English-speaking world and in the world using other language and using German. I know about German because I am German. Designers are not modelers. In English, design is probably a little bit more into this world of modeling. I would say I like to speak about a designer and a digital sculptor. I experienced work where a digital sculptor means all of friends that I have worked together with a designer who didn't work on Alias or on ISM Surfer or anything else, and not on clay, but who just gave the design intention and to guided the design until its finishing stage. So when we talk about concept design, you remember in the webinar I had all these different stages. In concept design, the designer is the designer. But when it comes to Class A, I believe that the designer is not there anymore. You should follow the process and you should guide the process and supervise the process. But I believe that for Class A modeling, you need people dedicated to do that in order to get good results. And there, the digital sculptor doing the Class A modeling is not a designer anymore. That's what I believe
Excellent. Well, yeah, this is the end of our webinar. I'd just like to thank everyone listening, watching, for joining us today and for all your excellent questions. Please remember that this webinar will be uploaded into our archives and made available, in the future to anyone who wishes to view it, maybe, and also people who couldn't be here today to view it live. You can access this and all our previous webinars under the Process tab on the Car Design News homepage. I'd also like to obviously thank Uwe for a fantastic presentation and for fielding all those great questions from the audience. And just to say,
and I thank you, and I thank the audience.
Excellent. Yeah, so thank you very much, and also please don't forget to join us. As in fact, Uwe mentioned earlier, we've got a next webinar, the 26th of September, which is a presentation on concept modeling with Autodesk's Maya software. So follows on neatly from the topics we've been covering today. Thank you all, and goodbye.
Bye-bye.